Money, money, money.
Hi, welcome back. Today, you will learn dissecting the first Visual Basic program you created.
In this lesson, we want to start the process of dissecting this tiny little application that we wrote that simply prints hello world to the screen. So I want to spend a little bit of time and take a look at that module1.vb file that we were working in as a basis for future exploration of Visual Basic. So I didn't point this out in the previous lesson, but I can end the program in one of two ways. As you probably saw me do, I clicked the little red X in the upper right-hand corner. That's one method. The other way that I can end this particular program is just to hit the Enter key on the keyboard, and we'll discuss why that is in just a little bit. There's another way. Whenever you're running the application in debug mode, you'll come to learn that you can still work in the Visual Studio IDE and you can still see how the application is executing. We can use the little red stop debugging button in the toolbar to stop it as well. All right, but at any rate, any of these actions will stop and we're back writing code again. All right, so I hope that you can see how the actions that you took while writing the code and the code instructions that you created are manifested when running the application. But what I really want to do is cement these ideas in your mind because they provide the foundation for everything that comes next. So what we're going to do is start on the inside and work our way outward. So let's start with the code that we actually wrote. We'll start with the basics. We used a programming language called Visual Basic. Now there are many programming languages in the world, but at this moment, Visual Basic is one of just 2 or 3 languages used to create .NET applications. Visual Basic is one of the main programming languages that Microsoft supports in Visual Studio. So if you're committed to learning Visual Basic, then I recommend that you learn as much about Visual Basic as you possibly can over the coming days and weeks through this series of lessons, through books, whatever the case might be. It's probably one of your better choices when you're just getting started in programming. If you're seeking a career in software development, you might want to highly consider learning C# as well, or maybe starting with C#. It just depends on what your goals are. Most developers aspire to master one programming language when they're first starting out, but once you master a single programming language, learning a second and subsequent language is a lot easier because many of the same concepts will transfer over even if the syntax is just a little bit different. As somebody who's been writing code for and developing applications for over 20 years now, I assure you that Visual Basic is a great language to start with. In fact, even though I took some programming classes in college, it wasn't really until I taught myself how to write Visual Basic way back in 1993, 92, somewhere along those lines, with this book. And if you take a look at it, it's all bent up and it's got food and hair in it. It's disgusting, and it's awesome because I spent every waking hour with that book, pouring my heart and soul in learning how to program in Visual Basic. So that's how I got my start, and so I can recommend it on that basis. But today I typically use C# and other programming languages when I'm building Windows and web apps. All right? So you will change and your preferences may change over time, and that's okay. But Visual Basic is a great place to start. So when you learn how to write applications with Visual Basic, learning the syntax of Visual Basic, or in other words, I guess you could call them the nouns and the verbs and the punctuation of the programming language. Well, that's half of the battle. The other half of the battle is learning about the related pre-built functionality available to the programming language. Now in our case, Microsoft has created something called the .NET Framework. I'm sure you've heard of it. And while that sounds kind of mysterious and you may not actually understand fully what it does, I'll bet that you have at least some idea or some familiarity with it. For right now, just know that, first of all, it's not all that mysterious. It has a very specific purpose, and it has multiple parts to it, and we're just going to focus on 2 of those parts in this series of lessons. So the first part that concerns us is what's called the class library, the .NET Framework class library, also known as the FCL. It also is known by another name called the base class library. I'm going to come back to that reference much later in this series of lessons. But either of those terms, or the BCL, FCL, base class library, framework class library, any of those terms describe this library of code that Microsoft wrote to take care of difficult tasks so that we, the developers who are building applications for businesses or for ourselves, we don't have to worry about those sorts of things. So there are library functions for just about everything you can possibly imagine as a programmer, for working with math operations, or working with text, or displaying things to the computer screen, whether in a console window or in a nice Windows form window, developing web pages, transmitting information over the internet, you name it. There is probably a function out there developed by Microsoft that will take care of it. Part of that library of code that you get whenever you build applications in the .NET framework. So the second part of the .NET framework that we're going to be concerned with is called the runtime. It's also known as the Common Language Runtime, or the CLR. You can think of it like a protective bubble that wraps around your application as you execute it on an end user's computer. I use the term or the phrase protective bubble to mean that the CLR takes care of the low-level details for you, so that you can focus on what the application should do and less about how to interact with the computer's operating system, how to manage memory, how to work with the hardware on that particular computer, and so on. Furthermore, the CLR provides a layer of protection for the end user so that you, the malicious evil software developer, you can't do much harm to the computer, to the user's computer, at least not without them knowing about it, without their approval. All right, so for right now, it's the .NET Framework class library that I really want to focus on. When we typed in the phrase console .write line, we were using some code in that library, and that code knows how to display text in a Windows command line window, like we saw, that black window with just the text printed out in white letters. All we have to do is tell it what we want displayed. Hello world. That's the important part. We don't care how it writes the text to the window. We just care that text gets displayed. And so when I wrote this code, I made sure to emphasize that you have to write the code in the correct place. Otherwise, the application will encounter an error when you try to run it. In fact, I demonstrated to you what would happen if we put that code outside of the proper code block. The correct place was actually inside, between that submain and end sub, which again defines a code block. And that code block, this particular type of code block, is called a sub procedure because it has the word sub, end sub wrapped around it. All right. This innermost code, it has a name, and its name is main, and this main code is of type sub procedure. All right, that's a way to think about it. It's a special method actually that will be executed when the application is first executed by the end user. It will go to the main sub procedure first and execute that code. All right, so before I move past that sub main part, we also saw this, or we wrote this console.readline. Do you have any idea what that code does? Well, if we were to comment that code out, and I'm just going to talk about commenting in the next lesson or so, but I'm just going to put a single quote mark. It's right below the double quote mark. I'm going to put it next to the console.readline, and I'm going to, you'll see that it turns to green. Okay, so that's a note that this code will not execute. We're commenting it out. We're eliminating it from compilation. When I do that and I hit the run button or the start button, notice that our application flashed a screen and then went away, and we're back debugging our code again, or writing our code. All right, so this read line, what it does is it stops the execution of the code and it waits for the user to respond by hitting the enter key on the keyboard. Of course, we can circumvent that by hitting the X in the window and things of that nature, but that's its purpose, is to stop execution long enough so we can digest what actually happened on screen. And that's why we're going to add it to just about every code example that we write as we build applications here in the Windows console. Okay, back to the code. You can see that there's 3 levels of indentation. There's the module level at the very leftmost border, and at this point, mine has kind of gotten moved around a little bit, but there you go. You can see it now. There's one column, and then tabbed over another column is the sub main end sub column, and then inside of that there's the code that we actually wrote. So wrapping around that sub main is that module, module 1, end module. And so you can think of this as a series of containers. A module is simply an organizational tool, a way to keep your sub-procedures organized. You put all of the sub-procedures that are related together in a single module. So what do I mean by related? Well, that's really up for you. That's up to you, the developer, to decide. And as you get deeper into programming, you're going to come to understand that there are philosophies and approaches to writing code that will dictate where the code should reside in your code base, in your files, okay? So for now, let's keep it really simple. The main takeaway for now is that code is organized into sub-procedures and modules, and you have some blocks of code that reside in other blocks of code. And they have names, like this has the name module 1, this has the name main, and so forth. All right, so again, let's take a look at this line of code that we wrote, the console.writeLine method. Here we're executing what's called a method, and this method was written by somebody else at Microsoft. It knows how to display textual information to a command window like we've seen. At a very high level, modules and sub-procedures are roughly equivalent to methods and classes. Now, I cringe a little bit at that when I say it, because a class and a method are so much more than just the modules and the sub-procedures. It's so much more than just a mere organizational tool. Classes and methods open us up to a larger discussion of object-oriented programming, which is an important topic in software development. The .NET Framework class library itself was built using the principles of object-oriented programming, as well as techniques and constructs like classes and methods and other things like properties and events. So it's vital that you learn about using classes that other people wrote, like we did here, even if the first applications that you write are merely composed of sub-procedures and modules, all right? So we'll talk about how to create your own classes and methods a little bit later in the series, mostly as a means of just understanding more about the .NET Framework class library, mostly as a means of getting you kind of introduced to some of these ideas that you'll learn more about throughout your programming career. Just know that this word console is a class, and it's just one of thousands and thousands of classes in the .NET Framework class library that we can utilize in our applications. So each class has one or more methods that can perform a specific task, and each of those methods are loosely related to this idea of, in this case, a console, right? So there's the console write line, the console read line in line number 2. Its purpose, as we said a moment ago, is to wait for the end user to type in information, and then when the user hits the enter key on the keyboard, it will continue to execute the remainder of that code. So in our case, again, we're using it to stop the application from completing and disappearing so quickly that we couldn't tell what was actually printed to screen. But as we'll see in a later example, it's also used to retrieve information from the end user that they type in so that we can evaluate what they typed and then take some action as a result of that. So both this write line method and this read line method are organized into a single class named console. Both methods deal with interacting with the command window, the console window. So it just makes sense that they're both organized and live inside of this console class, or are related or encapsulated inside of this console class. So we're utilizing, or we're leveraging code that's been written by somebody else merely by referencing the name of the class and the name of the method that we want to use. Notice between those, separating the class and the method, is a period or a dot. This period is called a member access operator, or a member accessor. In other words, we can access a member of the console class by using a period after the name of the class and then typing the name of the member, or rather the method, the member of that class that we want to execute, right? All right, so next, both the write line and the read line methods have a pair of parentheses immediately following them. However, only the write line method has a value that we typed in between those parentheses. So that value is what's called an argument, and we're passing that argument into the method for its consideration, for its use. The value is an argument that we pass into the method as an input parameter. In other words, the write line method allows you to send it information that you want displayed on screen. So the write line method defines an input parameter, and then we pass in a literal string hello world as an input parameter argument to the write line method. We literally want those exact words displayed in the console window. All right? And so I keep using this term literal string. By this I mean a hard-coded sequence of alphanumeric characters. That's what a string is. We create a literal string in Visual Basic by using the double quotes that I keep doing air quotes here. By using two double quotes, we surround any grouping of any sequence, any string with those double quotes, the alphanumeric characters that we want to define as a literal string. So as you'll learn, this is just one type of data that we could send to the write line method. In addition to just textual information, alphanumeric characters, we can actually send numeric characters that we intend to be used as numeric values that could be used in mathematical equations and so on. All right, and dates, and there's all sorts of data types. We'll talk about those more as we go throughout this series of lessons. All right. But the key idea here is that some methods can accept input values, such as a literal string in this case, which is then used by the write line method to display to the console window. We'll come back to the notion of methods in the future, but just know that whenever you see the parenthesis, that we are going to be calling a method, all right, that somebody else wrote, or maybe that we write, as we'll come to learn. So next I want to talk about the fact that we wrote 2 lines of code which are 2 complete instructions in Visual Basic. Now, unlike other programming languages, you can only put one instruction called a statement on one line of code. Now, there are ways to make a really long line of code split up into multiple lines so that it doesn't, carry off to the right-hand side. You'll see me do that throughout the series of lessons. I'll show you how to kind of circumvent that built-in 1 line per instruction, 1 line per statement rule. But in a sense, 1 line, 1 statement, 1 complete thought in Visual Basic. In other programming languages, you can have multiple commands on a single line, but you cannot in Visual Basic. At least you can't easily. And then also notice we talked about the indentation. That's completely optional. The computer doesn't need that indentation, but it's so important for humans that the IDE will add it by default. Why do you suppose that is? Well, doesn't it make it a little bit more readable? And now that I've explained what the different distinctions are between, submain and module 1 and things of that nature, it makes it a little bit easier for us to pick up and read what's going on screen. So most people think so, and that's why Visual Studio adds it by default. Along those same lines, Visual Studio color codes the text that we typed in. For example, class names and module names have this aqua blue color, all right, or green color. Special Visual Basic reserved words are in a bright blue or royal blue color. String literals are in this red, this dark red color. And so when you have those distinctions, it makes your code more human readable. All right, so expanding out from the code that we wrote, notice that we're working inside this file named module1.vb. It's this little label that we see on this tab at the very top inside the main area of Visual Studio. If we look over on the right-hand side, we're also going to see that file listed here, module1.vb. And actually, kind of to focus your attention out a little bit more, there's this window called the Solution Explorer. It has a tree view of several items. For example, at the very top, there's this solution called Hello World, and then second, an entry called Hello World again. This is actually the project entry. And then beneath that, we see a couple of icons, and then finally our module1.vb. In the next lesson, we're going to learn a little bit more about the Solution Explorer and about the other windows that are available to us all around and inside of the Visual Studio IDE. But simply put, the Solution Explorer is our main navigational device to find the other code files and the settings that, once compiled, will comprise our finished .NET assembly that we can execute ourselves on our own computer or put on somebody else's computer. So the end goal here is to compile up all these settings and all this code that we've written, and for there to be a final executable. So at any rate, to kind of delve into that a little bit more, files and other important settings are organized into projects, which are then compiled into a single .NET assembly. We'll talk about assemblies a little bit later, but an assembly is just a fancy word for either a .exe or a .dll file. All right, you've probably seen those on your hard drive if you're familiar with working with computers. Furthermore, one project or one or more projects are organized into this larger container called a solution. In many cases, when you're getting started, you're only going to have one project inside of a solution. But as you build more complex applications, it's highly likely that you're going to need to manage multiple projects that are somehow related together. Again, the reason might not be obvious at this point, but as you continue learning Visual Basic and you're building more complex applications, business-oriented applications for large enterprises, this becomes a crucial code management strategy. So for now, just accept this extra layer of solutions that own projects, and trust me, it's important, but not until we move past the basics, all right? So the big question at this point is, where are your files actually stored? We see them in Visual Studio, but we know that they have to be somewhere on our file system. Where are they? So when you rely on the Visual Studio IDE to actually create a project for you, like we did when we went to File, New Project, the New Project dialog popped up, we gave it a name. There was also a path underneath that I didn't point out at the time, but that's where it actually will save all of these projects and all the settings for this given project, or all the files in the project, I should say, to our hard drives. So what we want to do now is open up Windows Explorer and navigate to that spot, just so you can see where your code is actually stored. So what we want to do is, this will be different depending on which operating system that you have. I'm using Windows 8.1, so I'm going to go to this PC and I'm going to look under Documents. And under Documents, there should be a folder called Visual Studio 2013, or maybe 2014, 2015, 2020, I don't know, whatever you have, right? And if we drill into that folder, you can see that there are a number of subfolders. The one in the middle that I'm looking for is called Projects. If you double click the Projects folder, you can see that there is our Hello World Solution folder. If we open up the Solution folder, you can see it has a solution file. In fact, if we were to move this over, you can see that while the file extensions are not shown, let me change that real quick. Let's go to View Options, and we'll go, we're going to deselect Hide Extensions for Known File Types and select Apply and click OK. And so now you can see that the file extension .sln is a solution file for Visual Studio. All right, so we're going to drill into the solution folder's subfolder called Hello World, which this will be actually the project folder. And now we see that there's this hello world.vbproj. So that's going to be the project folder, or the project file, that contains settings that we can set, and I'll show you how to set those settings a little bit later. Then there's also this module1.vb. Okay, we know what that is. And then there's this app config, which we see represented here as well in our Solution Explorer. If you take a look in this bin directory, you're going to see that there is this folder called debug. We'll come back to that in just a moment. Let's go back out to this hello world.vbproj, and what I want to do is open it up and take a look at it. I'm going to right-click it and select Open With. And this is very dangerous. I want you to immediately deselect Use this app for all VBproj files. Make sure that's deselected. Don't be angry at me if you leave it selected and you accidentally click something. Then I'm going to click More Options and choose Notepad, which should be one of the options. And all that I really wanted to point out here is that this file format is just a bunch of XML, Extensible Markup Language, and it's frequently used in software development as a means of adding configuration settings to an application or a project. So this is sometimes known as metadata. This file contains file paths, the previous state of the project, like which windows were open when we previously were working in Visual Studio, and other important settings related to the project itself. So this is really important. Do not, under any circumstances, actually modify this file. Doing so might corrupt your Hello World project beyond repair. So please don't touch it. In fact, we probably should have closed Visual Studio before we even started dealing with this, but I'm too far in at this point. Let's not touch anything at this point. And you can feel free to scroll through it. I don't think that most of it will make sense at this point, but all of these settings as we look through it are very important to Visual Studio and to .NET as we compile our application into an executable. So I just wanted to demonstrate that there's really no magic going on here. It's just a bunch of configuration settings that comprise a project. It says what files belong to this project, okay, and then when you get ready to compile, the compiler is going to look at that, going to say, oh, I need this file, and I need this file, and I need this file. Let's compile them into an executable, all right? And the same thing is true with the solution. We're not looking at that, but it's just a bunch of XML as well, just at a higher level to contain the projects that belong to the solution. All right, so I'm going to close Notepad. If it asks if you want to change, save any changes, don't save any changes. That would be a big mistake at this point, all right? If you accidentally typed something in or your cat ran across your keyboard as you were looking at that file, don't save the changes. All right, what I want to do is continue on and talk about the bin subdirectory. And we see in here we have a debug folder. The word bin is short for binary, and it denotes the binary executable output created by the compilation process. So what I want to do is open that file or that folder to reveal its contents, and you should see that there are actually an exe and then a number of config, PDB files, and so on, even an XML file, all right? So this is the debug version of the application that was created whenever we click the Start button on our toolbar. And the debug version contains not only the executable file itself, but also additional information in the form of some of these files that allows the Visual Studio IDE to keep track of what's currently happening inside of the executable as it's running. So as you're going to see, one of the most powerful features of the Visual Studio IDE is the integrated debugging environment, allowing us to watch code execute line by line as a means of determining where the problems with our code might actually reside. More on that later, but that's a very cool feature and one of the biggest reasons why you should use an IDE. So at some point, we're going to be finished working on our application. We're going to be ready to release this to end users, to our friends, or to our customers, whatever the case might be. And so we'll want to create a release version of our .NET assembly that we can distribute to others, put on their computers. And we don't want it to be bloated with all this extra information that's used for debugging in Visual Studio. We don't want the speed of the release version to be affected with all this extra information that was used during debugging, and therefore we want to create a release version of our code, and we'll do that in just a moment. So back here in our debug folder, you'll see that there's a hello world.exe. If you double click it, the application actually runs. I think that the last time I built it, I removed that line of code, that console.read line. So this time when we run it, it should actually stay on screen for a moment here. And so then the other files here have various jobs relating to the process of debugging, keeping the IDE in sync with the code that's currently being executed inside of the .exe, the .NET assembly. And we'll see this in action in the very next lesson. However, the key idea here is that this debug version is not optimized to be released to an end user's computer because it contains all this extra stuff, all this extra information that's used by Visual Studio for debugging purposes. And we don't need all that when we're ready to finish it and deploy it to somebody else's computer. So ultimately what we want to do is create a release version of the application for distribution to end users. And so we'll do that in just a moment. Actually, we're going to do that now. Let's go and to this little drop down that's next to the Start button. And we currently selected to debug, but if I were to drop it down, you'll see that there are some other selections as well. We already know that the debug option is going to create a debug version of the application for us. Obviously, the release option is going to create a release version of the application, and then there's this configuration manager ... Whenever you see the ellipsis at the end of a phrase in Visual Studio or any application, that generally means that there's going to be another window that's going to pop up afterwards. So when you select Configuration Manager, it opens up the Configuration Manager dialog, and it allows you to create different configurations. And this is applicable whenever you have multiple projects in the solution and you want to mix and match between debug and release versions for each project, or you're targeting a different platform for each project. So for example, right now we're set to run on any platform, but we can go specifically with the the x86 platform or the 64-bit platform, specifically because we have code in our application that targets one of those platforms. And that's really an advanced topic, so I just want to ignore that option for now. Let's go ahead and just click out of that. And let's go ahead and just close this dialog, but we're going to go back here and select Release. Now I want you to notice we're going to go back to our bin directory. And our bin directory has a release version. Somehow we actually created one. I didn't mean to do that. I'm going to go ahead and delete it. All right, so this is going to be a little anticlimactic because I've already created the release version and now I can't for some reason delete it. But what we want to do, if you haven't done this already, is select the release option and then choose build and then build solution, and that will create the release version of the application. And then when you open it up, you might notice that, well, there's a lot of files in there. I thought we were going to build a smaller, more compact, concise version of this assembly. Well, the truth of the matter is that in these simple examples in the console window, the output is going to be identical between the release and the debug version. When you get into advanced scenarios, however, you have the option as a developer to conditionally compile certain code based on the configuration that you've chosen. So how and why you'd want to do that is more of an advanced topic. Just be aware of the difference between the debug and the release version for now. Okay, so in this lesson we covered quite a bit of ground, right? Let's recap it just really briefly. We talked first of all about the code that we wrote in the previous lesson. First, we talked about the organization of the code, how code is organized within code blocks. So we added code to a sub-procedure code block called main, right here, all right? And that's executed automatically whenever a user runs the application. It has a special function within Visual Basic. We learned how related sub-procedures should be organized into modules. Similarly, through our use of the .NET Framework class library, we saw how methods like WriteLine and ReadLine are organized into classes. And so we used methods written by Microsoft to work with the console window. In fact, both of the methods that we worked with, the ReadLine and the WriteLine methods, were organized into the console class. We accessed that functionality, and we accessed the console class by using its name, console, then using its methods by first choosing the period as the member access operator, and then selected the member, the method that we wanted to use from that class. So we also, in our first line of code, we passed a literal string hello world enclosed in double quotation marks, which makes it a literal string, and we understood what a string was. It was just a collection of alphanumeric characters that were grouped together. We passed it as an argument to the WriteLine method. Now, we don't care how the WriteLine method actually works its magic. We just care that it can display in a console window whatever we tell it we want, okay? And we talked about the syntax of Visual Basic, specifically how we can only add one Visual Basic statement per line of code. We also talked about the lines and the spacing and indentation. These don't affect the code per se, however, they make it easier for we as humans to read and understand. Likewise, we noted how the IDE's code editor will color certain code to further assist in the readability of that code. We used the Solution Explorer here to understand the organization of our code. We talked about projects as a means of collecting files and other settings together that will be required to generate a compiled .NET assembly. And we briefly explained how multiple projects can be assembled into a solution. So that solution is the umbrella, but we said we don't want to talk about that just now because it's a little bit more of an advanced topic. Finally, we talked about where you can find all the files for your project, as well as the folder structure for the compiled versions of the .NET assembly debug version and the release version. So the good news is that we're finished with a lot of the tedious parts of learning .NET, at least from a practical perspective. You're well on your way to learning .NET now, and so now that we've sucked you in, you got to continue on. We'll see you in the next lesson. Thank you.
Cool. See you at the next lessons.